students. This is JRF Soil Science classes series under the topic Soil Structure Part 2. I think the last class you have understood everything, and if you have any doubt you can ask in the comment section. So in this video I would like to take the topics like soil structure and pore space, soil structure and water flow, and rest we will deal in another class. So this is an important concept you have to study. Actually, the structure, soil structure, we have studied that it is a way by which the soil separates are arranged to different aggregates. So we have seen in the previous video. I think if you have any doubt, you can ask. Okay, you are free to give me suggestions also. So what happens is that this arrangement of the soil particles will, if these soil particles are arranged in any way, there will be some spaces between the particles. So this is for sure. That means if we arrange some spheres like this, you can see these spaces, and these spaces constitute the soil pore. So this arrangement results in different sized soil pore. And you know the pores means empty spaces. Okay. So the main factor which influences the type of pore in a soil, it is a soil structure. So there comes the importance of soil structure. So we can frame a different definition for the soil structure. That means it is the arrangement of various sized soil pore in a certain structural pattern. Okay, let me take the pointer. Okay, so it is the arrangement of various sized soil pore in a certain structural pattern. So you understood what is a soil pore, how it is formed. Okay. So in this picture, you can see these rounded things. These are aggregates. You already know what is an aggregate. It is it consists of soil particles together with cementing agent after flocculation, which forms an aggregate. So these aggregates, when they are arranged, there will be empty spaces. These are empty spaces, and inside the aggregate also there will be soil particles. So when they are cemented together, also there will be pore. Pores will be created. So within the aggregates, the pores are known as intra-aggregate or textural pores, and between the aggregates, this larger pores, they are known as inter-aggregate or structural pores. So they structural, textural pores and structural pores. You have to know the difference between textural pores and structural pores. Textural means inside, and structural means between aggregates. So they are also known as intra-aggregate and inter-aggregate. So intra means inside and inter means between. Understood? So another concept is that we can call macropores and micropores instead of inter-aggregate and intra-aggregates. So macropores means they're big pores. Their size is diameter is greater than 0.06 millimeter, and they are actually inter-aggregate pores. They occur between the aggregates of individual grains in coarse textured soils. So these are big pores. They will allow the movement of air, drainage of water, and provide space for roots and organisms in the soil. So they will not hold the water. They will allow the movement of water, flow of water and air. So they are known as aeration and drainage pores. While micropores, you can see this is aggregate, and inside that spaces, empty spaces, they are known as micropores. Their size is very small, that is diameter less than 0.06 millimeter. So they occur within the aggregates or between the individual clay sized particles. So inside there will be clay size particles, soil particles. So between that, or you can say within the aggregate, inside aggregates, the pores are known as micropores with diameter less than 0.06 millimeter. So, they are also known as capillary pores, and they are filled with water and are too small at low, which will not pass the air. They will hold the water only. They will not allow the movement of air and water. So water movement in micropores is slow, and some of the water is tightly held by the soil colloids, is unavailable to plants. They will retain water, and some part of the water is retained so tightly, so the plants cannot utilize it. They are known as water retention pore. So understand the concept, like macropores diameter, then what their function, like that. Micropores diameter is less than 0.06 millimeter, and they are known as water retention pore. And from the picture you can clearly see this is the enlarged picture. This is aggregate. Between the aggregate it is interaggregate pore or macropore, and inside the aggregate it is intra-aggregate pore or micropore. Okay. Then, a well-aggregated clay soil tends to have a balance of large aeration and drainage pores and small water retention pores. So, a well-aggregated soil which is a good aggregate, which have good aggregation, they should have a balance, equal amount, equal proportion of this micropores and macropores. Good soil structure is associated with small or medium-sized aggregates with abundant pores with both within and between aggregates. So, for a good soil structure, there should be a balanced amount of macropores and micropores. Next, we can see an important topic, that is porosity and pore size distribution. I have already told that the pores, amount of pore in a soil depends on structure mainly, and it also depends on texture. And indirect factors which affects the porosity and pore size distribution is organic matter, bulk density, management factors, like tillage, cropping, and irrigation. So in porosity means the amount of pores, is it? So in sandy soil it is 30 to 45 percentage, loamy soil 40 to 55 percentage, clay soil 45 to 60%. So highest porosity is for clay soil. Clay soil, the number of pores will be more, but size of pore will be less, because in clay soil micropores are dominating. While in sandy soil, it will not retain water. You all know that. So, sandy soil porosity will be less. So, this 45 to 60 percentage porosity means out of 100 percentage of soil space, 60 percentage will be pore. It is a meaning. So, an important concept is that distribution of different sized pores is more important for the plant growth than the total porosity. So when a sentence comes like total porosity is more important than the distribution of different sized pore, that sentence is very wrong. So you have to understand one concept. In a soil, how much pores is present, that is not important. How that pores are distributed, like micropores and macropores, how they are distributed, that is important for in case of plant growth. So remember this sentence. So I'll say its meaning. Like in sandy soil, pore size will be larger. In sandy soil, macropore is dominant and porosity will be lower. Porosity means total amount of pores. Their large sized pores. So compared to clay soils, their porosity will be lower, and sandy soil have more macropores and they are uniform sized pores. So less water and nutrient holding capacity is there. While in clay soil, pore size is smaller and porosity is higher, but variable porosity is there. And in clay soil, more micropores are present and retain more water. They will not allow the movement of water. They will hold the water. Hence, in clay soil, the water movement will be restricted. They are poorly drained. Hence, you can see total porosity, like here the distribution of pore size is important. And in sandy soil, most of the pores are relatively large and nearly of uniform size. Hence, once these pores get emptied at a given section, only a small amount of water is held in the soil. So this look at this sentence. In sandy soil, most of the pores are relatively large. Means that there are macro pores present in sandy soil and they are uniform size. So when we give a suction, that means when we dry the soil, only a small amount of water is held in the soil, because in sandy soil it will allow the movement of water. So when we dry it, water will move easily, and at a given section it can't hold water. So that is the meaning of this sentence. While in clay soil, pore size distribution is more uniform, therefore water gradually decreases with increase in section. Here clay soil, uniform distribution of pore is there. So means it will retain more water. Unlike the sandy soil, it will retain more water. When we dry the soil also, there will be gradual decrease in the water. This is seen from the graph. So this graph shows the variation of water content while we give a suction. That means when we dry. High suction means when we dry. At a high drying means that drying condition, we will say high suction. Okay. So this dot is of sandy soil and this line is of clay soil. So you can see at low suction. Low suction means at means when we are not drying, at saturation level, you can see the water level of this water content of sandy soil here. It is less than the clay soil. This is because of the presence of macropores in sandy soil, which allow the movement of water, which will not retain water. Hence, this water content is less for sandy soil. While clay soil, because of the presence of micropore will retain water. Hence, water content will be more. And when we dry, means when we increase a section, that means when we dry, for clay soil you can see the water content gradually decreases, like uniform. It looks like a line, straight line. So this is because from micropore, it will retain more water. Water loss will not be there. Means it will be very slow, and the water content will decrease gradually. While for the sandy soil, it will decrease faster because the presence of more macropores is present in sandy soil, which will allow the flow of water. So you can see a faster decrease in the water content. That means up from here at this level of suction, water content became this much. But you can see this much water content for we have to give this much suction for clay soil to become this much water content. Say it is when it is 1%. For 1% water content, we have to give this much suction for sandy soil only, but this much section you have to give for clay soil. So this is the meaning of this graph. So in sandy soil, at a given section, only a small amount of water is held in the soil because of the presence of more macropores, and clay soil, water gradually decreases with the increase in suction. Hence, this distribution of different sized pores is more important for the plant growth than total porosity. Next concept is that the amount of water retained at relatively low suction, that is less than 1 bar, depends primarily upon the capillary effect and pore size distribution, and hence is strongly affected by the soil structure. So we can study like what happens at the low suction. So I have already told suction means a pressure. When the soil retain water under low suction, water will be held due to capillary force. Here you can see capillary effect. So the capillary in capillary pore or micropore, water will be held. So they are very small pores, you know. So they will pull the water upside and they will hold it there because they are known as water retain pore. Okay, so actually the soil structure will determine the size and arrangement of these micropores and macropores. In well structured soils, there will be good pore distribution, and it will be when it have more amount of micropores, it will hold more water. So that is the meaning of the first sentence. So at a low section, less than 1 bar, the water retention is related to capillary effect or capillary pores. That capillary pores is affected by the soil structure. Hence, this sentence says that at low section, the water retention depends on the soil structure. The next sentence you can see water retention in high suction range is due to the surface absorption and influenced mainly by texture. So what this sentence means is that at high suctions means when we are drying the soil. So when the soil is very dry, the water retention is at a high pressure. So at this condition, what happens is that water will hold more tightly. When we dry the soil, dry means water content will be removed, but the how much water is left on the soil, that will be held tightly to the surface of these soil particles by surface adsorption. So here, what happens is that surface adsorption happens. Adsorption means it will be hold on the surface of soil particle. So water molecule will stick to the surface of soil particles, and this adsorption will depend upon how the how what at what proportion these soil particles are present in the soil. So the proportion or relative abundance or means proportion of sand, silt, and clay, that is known as the texture. So that's why the this sentence says that high suction range, the water retention influenced by texture. So sand will not retain water because of the absence or means in clay soils have a property of water adsorption. Because of that property, clay will retain more water. So water retention at high suction range is due to surface absorption and it is influenced by texture. So you have to know the concept, just to understand the concept only. Then and this both sentences are very important in terms of the JRF. Okay. The next concept is this graph. So this graph shows the variation of water content in compacted soil and aggregated soil at a various section level. So when this dot line is compacted soil and this line is aggregated soil. So when the soil is compacted, I will read this sentence. Soil compaction decreases the total porosity, especially by reducing the volume of large interaggregated pores, thereby resulting in decreased water content at saturation and low suctions. So what happens during compaction, soil compaction? While when we apply pressure on the soil surface, pore will be there will be distribution, not distribution, there will be means arrangement of pores. Some pore will be destructed, then pore size will decrease. That means total porosity of the soil will be decreased. So the large pores, that is macropore, will be destructed. It will be destroyed when we compact a soil, when we apply pressure in the soil. So there will be less space for the water to move through. Hence, for the compacted soil at low suction or at saturation, water content is less compared to well aggregated soil. So, when the water is at saturation and low suction, water content will be decreased because of the destruction of macropore, which allow the movement of water. Okay, so compared to the aggregate soil, compacted soil will have low water content at low suction level because of the destruction of pores. So that happens during soil compaction. But when we increase the suction, you can see the water content decreases in the compacted soil like this, and water content decreases in both soil. Water content decreases like this and reaches to the point. So at high section you can see the water content for both compacted soil and aggregated soil is same, equal. Okay, so at what you can see is that water content is same for both the soil. This is because while compaction only macropore will be destructed. Micropore and intermediate size pores will not be destructed. It will be present inside the soil, inside the aggregate. So in aggregated soil, it will not be destructed. So at high suction, that is at a high dry condition, water content will be similar. Okay. Now, so we can conclude that soil compaction will affect the water retention at a very wet and just moderately dry condition, but at extremely dry condition, that is high suction range, both the compacted soil and aggregated soil will behave similarly in case of water content. So the volume of intermediate size pores is large, but the intra-aggregate micropores remain unaffected by the soil compaction, and for this reason, the soil moisture retention for the compacted and aggregated soil may be nearly identical at a high suction range. Then, the previous slide we saw how the soil structure directly influences the size of pores. So the size of pores will determine the infiltration of water, retention of water, aeration, drainage, etc. So this slide shows the relationship between the soil structure and water flow. So you can see single grain, granular, blocky, prismatic, pathy, massive structures and the flow of water. So first case for the single grained soil. So you have studied about single grained soil. They are loosely arranged soil particles. They will not form aggregate. So large spaces will be between them, and through these spaces, water can move rapidly and quickly. For example, you can see in the sandy soil, it will water will move rapidly, and you can see granular structure. Granular structure is a stable type of structure, and it contain rounded aggregates. You can see in the picture. So between this rounded space. Particles, there will be so many spaces, so it will allow the movement of water. For example, you can see in the loamy soil, so in single grain and granular structure the water movement is very rapid. Next, you can see the blocky and prismatic structure. In blocky structure, you have already studied they are divided into so many blocks which will fit together. So when we pour water, uh, water can still move, but it will be much slower compared to single grained and granular structure. While in prismatic, these are the individual units are arranged like pillar or column like structure. So they will be fitted together, but the water will move very slower, means it will be slower compared to single grade and granular. So water flow in block and prismatic structure is moderate. Like the third case, it is of platy structure. So the platy structure, the units are arranged stacked together like a horizontal plate, which restrict the water movement because they are arranged horizontally. And when we pour water, water can't move. It will restrict the movement of water, but it will be very slower compared to all other soil structure. While in massive structure, the soil particles are tightly packed together. There is no aggregation, so there is no space for the water to flow, and this happens mainly in the compacted soil. There, the drainage is very poor, so you have to understand these concepts also. Hence, if you have any doubt, you can ask in the comment section. These all are about the classes of today. Thank you.